Hello students, today we will take one example of voltage shunt feedback topology and one example of current shunt feedback topology. Okay, first of all, voltage shunt feedback topology. This is the given circuit diagram of voltage shunt feedback topology. It is basically a negative feedback amplifier having voltage shunt feedback topology. Okay, I will do the step-by-step analysis of this feedback amplifier. Means we have to find out its gain, its input resistance, its output resistance, okay, and its output resistance including load. Okay, for doing the analysis, we have to apply our already started method. Okay, which consists of various steps. So we will do the step-by-step analysis. Already for previous two topology we have applied all the steps to analyze previous two circuits, but here we will take only the most difficult step in the analysis. Okay, rest of the steps I will show you, but I will not take those steps in detail here. Okay, so first of all, step one is the identification of topology. We already have taken this step in detail. We will directly go to step second now. Okay, what is step second? Step second is we have to draw the basic amplifier circuit. It is the most difficult, or you can say most important part of the analysis. So we will take only step 2 in our both of the examples. Okay, rest of the steps I will show you here. You may note down by this video, you may practice. Okay, but we will not take those steps in detail now. Okay, already we have done two circuits and taken all the steps in detail. So now you can do all the steps on your own. We will take only step second in detail now. Okay, what is step second? Step second is we have to draw the basic amplifier circuit. Here means we have to remove the feedback from this circuit, including the loading of each and every components. Means we have to include the loading of each and every component, but we have to remove the feedback from this circuit. Okay, so we have to draw the basic amplifier circuit of this feedback amplifier. For drawing the basic amplifier circuit, we have to draw the input and output circuit separately. For drawing the input circuit, we have to modify the output circuit. In case of voltage sampling, we have to short the output node. Okay, here we have to short the output node. Okay, so in case for drawing the input circuit, we have to modify the output circuit. For modifying the output circuit, in case of voltage sampling, we have to short the output node. In case of current sampling, we have to open the output node. Here the sampling is a voltage sampling, so we have to short the output node. Okay, by shorting the output node, this circuit will become like this. Okay, because we have shorted the output node, so one terminal of RF is grounded, one terminal is connected to base, so this can be redrawn like this. Okay, so this will become our input circuit. Now we have to draw the output circuit. For drawing the output circuit, we have to modify the input circuit. In case of series mixing, we have to open the input loop. In case of shunt mixing, we have to short the input node. Here the mixing is of shunt type, so we have to short the input node. By shorting the input node, your output circuit will become like this. Means your complete circuit will become like this. Okay, this can be redrawn like this. Okay, because this is shorted, and again this can be redrawn like this, because uh, one terminal or of RF is grounded now, one terminal is connected to collector. Okay, so this RF now has come in parallel to RC, because here also one terminal of RC is connected to collector and other is grounded. So RC, which is basically your RL, also load resistance, this comes parallel with RF, or we can say RF comes parallel with this RC. So this circuit can be redrawn like this. So this is our output circuit now. Okay, look, here we have omitted VCC. Look, and this depends upon the circuit. If we are comfortable in with VCC, so we can include VCC in our this step, or if we are uncomfortable with VCC, we can also shorted we can also short VCC to ground, because after this step we have to draw the equivalent H parameter model, which is basically AC equivalent model, and in AC equivalent model VCC is normally grounded. So we can consider VCC here, we can take VCC here in this step, or we can also short VCC in this step itself. Okay, so VCC is not a problem, but the input and output circuit is a bit problem for students. So that's why we have to consider this step carefully. Okay, we have to observe this step carefully. Okay, so now combined circuit will be like this. This was our input circuit, and this was our output circuit. Combining both the circuit, this will be our final circuit of basic amplifier. Okay, now after that we have to apply our step 3, 4 and 5, which can be easily applied. I am showing you here all the steps, but not taking in detail because it will take time, so you can practice it on your own. Okay, so this will complete your analysis of voltage and feedback topology. Okay, in our next section we will take analysis of current and feedback topology. Okay.